0.1 molar calcium nitrate, 1 drop of 4, and 0.1 molar sodium carbonate, 1 drop of 4. The two react together, and you can see the result. To 1 molar sodium hydroxide, 1 drop 4. Point 1 molar magnesium sulfate, 1 drop 4. Mix. Point 1 molar sodium nitrate, 1 drop 4. Point 1 molar potassium chloride, 1 drop 4. Mix. Chemical reactions, part 1b. For the first one, which is neutralization reaction, I'm using 0.1 molar sodium hydroxide, and I'm using 1 drop of full of it and transferring all of that into the test tube there. And I'm going to add few drops of phenolphthalein, which is used as indicator to detect any hydroxide ion that might be present. Next, I'm going to add 0.1 molar hydrochloric acid, and I'm going to add that dropwise because I want to see if there is any change. So in order for us to detect the change in color, I'm going to hold the card behind this. So drop by drop, I'm adding hydrochloric acid. When all of the sodium hydroxide is neutralized by hydrochloric acid, then the color changes to colorless. It's getting warm. So that's the first reaction. The second reaction on the right is gas evolution reaction. And that one, I'm going to use 1 spatula full of sodium carbonate in form of solid. Then I'm going to add 1 molar hydrochloric acid, there. The reaction effervescences, and there's a lot of bubbles being formed, which shows evolution of a gas in a solution. Don't forget, you're starting with solid sodium carbonate and not aqueous solution of sodium carbonate. Magnesium in form of a ribbon. This is how they are. Very flexible and they're silver color. Just going to go ahead and cut a bigger piece in here. So I have Bunsen burner in here. What I've done is I've gone ahead and closed the air inlet, which is up here, and the gas inlet, which is down below on the bottom of the barrel. I'm going to turn on the gas, which is back here fully, and then I'm going to, because this is closed so there's no gas flowing right now, I'm going to open the air inlet by 1, 2, 3 turns, and 1, 2, 3 turns on the air inlet, and 1, 2, 3 turns on the gas inlet. Then I'm going to use my lighter to light the Bunsen burner. So the flame is kind of flary. We want a hot flame, which means I can control the gas flow from down here from the gas inlet, and that makes the flame look bigger, but it doesn't change the texture of the flame. But I can change the texture of the flame by using the air inlet, and that's just giving it some air. Now we have a Bunsen burner as opposed to before, which was more like a candle really. So in here you have 2 cones, and there is a top cone which is kind of a little bit lighter blue, and the inner cone which is darker blue. I hope you can see that in your in the video. So the tip of that inner cone is the hottest part of the flame. So I'm going to hold the magnesium, and I'm going to hold it on the hottest part of that flame. It's going to burn with a bright light, so I turn my head so I don't actually look into it directly, but I look into it from the corner of my eyes, and I see that it's finished now. Once all of it is burned, as you see, the ashes stay on, and I'm just going to transfer the ashes into the test tube. Quickly, I'm going to turn off the gas, adding some deionized water to the test tube. As you see, what is formed in there, the ashes, not soluble, is on the bottom of the test tube, if you can see it. If I use my card, it might be giving you a better contrast there. And then I'm going to add a few drops of phenolphthalein. So as the water reacts with the magnesium oxide that's forming there, you see that color being formed. To be the composition reactions, I'm going to go ahead and turn on the Bunsen burner, and then I'm going to use ammonium dichromate, 1 spatula full, in my test tube on the left, and heat it and see the reaction. So turning on the Bunsen burner, ammonium dichromate, 1 spatula full. Then I'm going to heat the test tube after adjusting my flame to get the hottest part of my flame, which is the tip of that inner cone, to touch the bottom of that test tube. So you're looking for changes in the test tube. To see if you can observe any sign of a substance that was formed in there. Around here, there is a good sign of it. As you see, the color of ammonium dichromate also changed drastically, and the texture as well. Attention to the top of the tube and sides. Copper 2 sulfate pentahydrate. Small spatula fork. And heat. Part 2C, zinc. Six molar hydrochloric acid, 5 milliliters. Pop. Just showing you the reaction of zinc and hydrochloric acid close up. And as you see, after a minute or so, still bubbles are being formed. And I'm going to leave it until the reaction goes to completion. So this would be the hydrogen that's bubbling through the solution of hydrochloric acid, and now maybe a little bit of zinc chloride is being formed too. Chemical reactions, part 2C, reaction number 2. 0.5 molar copper 2 sulfate pentahydrate. And I need 3 milliliters of it. There, that's about 3 milliliters. And I need some zinc. I'm putting that in. Then adding copper sulfate to it. There is a change of color already. So I'm going to do the next reaction, which is also copper. So copper metal, but I have them in smaller pieces. So I'm adding a piece of copper wire, 3 milliliters of 0.1 molar zinc chloride. So that's about 3 milliliters, and that's going to go in the test tube with copper. I can go ahead and show you the first test tube, which was zinc and copper 2 sulfate from close up. It's changing to kind of reddish brown. If I use my card, it would be a little bit easier. Okay, so the color has definitely changed and it looks kind of muddy. But let's look at copper wires in the zinc chloride solution. So going back to the first reaction, now you see that copper color, which is kind of brownish red color, nicely being formed in there. And if I shook it, you see all the bits and pieces. The blue color is changing to kind of colorless. If I can change the background. If I move it between the two backgrounds, it might be easier for you to see that blue color is now actually really pale.